So today we're going to look at the scalar product or the dot product of vectors. It's kind of a little bit like matrix multiplication, but if you have two vectors in two dimensions, so if you had a 3, 1 vector and a dot product with a 2, 4 vector, now with matrices these wouldn't be able to multiply because the first one is a 2 by 1 and the second one is a 2 by 1 and the middle numbers don't match. But with vectors, you would multiply 3 times 2 to get 6 and 1 times 4 to get 4 and add those up. So the dot product would be 10. So you're multiplying similar components together and then adding them up. Same thing in 3 dimensions. You would have the first ones, then multiply the second ones, then the third ones. So this would look like U1, U2, U3, dot product with V1, V2, V3, and that's the result you would get. You'd multiply the components together. And the result is a scalar, and that's the reason it's called a scalar product. I guess when they write it, you write a dot in between. Maybe that's why sometimes it's called a dot product, and sometimes it's called an inner product, but I don't know why it's called an inner product. So, find the scalar product of those two vectors. So you could rewrite them. 2, negative 3, dot with 1 and 2. 2 times 1 is 2. Negative 3 times 2 is negative 6. So the dot product is negative 4. Not too bad. There's one in 3 dimensions. First vector is 2, negative 5, 3, 4, 1, and negative 7. Dot product will be 8, minus 5, minus 21, negative 18.